So, welcome back. We've been doing a whole lot of math, and the question becomes, why are we doing all this math? Why are we figuring out all of these skills to be able to compute measurements, know how to round, work scientific notation? And we haven't been doing a lot of chemistry. Well, let's do some chemistry. We're talking about all of these pieces kind of coming together to give us this tool that we use in chemistry a lot called the mole. And so we can go a little further. We can talk now about this special tool, a special unit that we've heard, but we haven't really talked about what it is and what it means for us. As we're going, feel free to pause, take your notes, record. There'll be some questions that pop up as we go here, just to make sure we're following along and we're getting some verification of the notes that we're taking. Don't worry, when we come back, we will be getting all together, we're going to review everything. We're going to make sure everybody's got a good working understanding, but we are going to keep nibbling to make sure we're not losing too much time with all these snow days. So we could take it a step further. The mole, it is technically short for originally molecule, and that kind of became its own thing. It's not the little furry thing. It is a unit of measurement. So the mole, it is just another unit. We use it in chemistry to start to group our amounts. Atoms are tiny. They're itty bitty. And so if we're going to measure some amount of matter, we need a lot of them. We need some way to kind of keep track of that. If I said a pair, you would think hopefully immediately one pair is two things. A dozen things is 12 items, and a gross 144. Usually we use that one for paper, right? You can have a dozen golf balls, you can have a dozen eggs, you can have a dozen soda cans, right? You can have any amount of these items. We usually have certain things we use them for. But when we say in chemistry a mole, that is 602 sectillion things. That would be 6.02 times 10 to the 23rd. There's that scientific notation. We've seen this number a couple of times. We haven't really talked about what it means. It is just an amount. I can have a mole of water. I can have a mole of carbon dioxide. I can have a mole of gold. I can have a mole of each of these things. And if I do, I have 6.02 times 10 to the 23rd of those atoms or molecules or particles, depending on what it is that I've measured out and kind of what it is that I'm working with. But it is just a number. It's just an amount, and it's where we've been working with all of this math. Cool. It was originally introduced by the guy by Avogadro, Amadeo Avogadro. He was kind of working with gases and figuring out, okay, how many particles, if I have equal volumes, how many particles do I have in each? And so he's kind of attributed with the discovery of this idea of kind of the mole. But it is just another amount. A dozen cookies, well, that's 12 cookies. If I had a mole of cookies, I'd have 6.02 times 10 to the 23rd cookies. I would have a lot of cookies, but it is still just an amount. If I had a dozen cars, 12 cars. If I had a mole of cars, it would be 6.02 times 10 to the 23rd cars. It's just an amount that we kind of truncate or abbreviate to make it more manageable for us to work with. If I had a dozen aluminum atoms, that would be 12 aluminum atoms. If I had a mole of aluminum atoms, that would be 6.02 times 10 to the 23rd atoms. Just an amount. It's just a tool for us to kind of measure how many particles are going on. We're going to use these later. Hold that thought. No, the number's always the same, but their mass is going to be different, right? If I had a dozen cookies and I had a dozen cars, I got the same number of both, but their masses would be pretty different. Same goes for our mole. If I had a mole of cookies or a mole of cars, their masses would be different because they're different sizes. And so the masses might be different, but it's still the same number of them. One mole of anything is 6.02 times 10 to the 23rd things. So if you had a mole of particles, 6.02 times 10 to the 23rd particles. If it was a mole of atoms or molecules or formula units, we're kind of getting tied into our nomenclature or our vernacular here a little bit. Particles is kind of our umbrella term. It refers to everything. If I said just atoms, well, that's an element. If I said molecules, that's covalently bonded. If I said formula units, now I'm talking ionic. And so it just kind of tells us a little bit more precisely what it is we are measuring. Mole of carbon would be 6.02 times 10 to the 23rd carbon atoms. A mole of water molecules would be 6.02 times 10 to the 23rd water molecules. If we had a mole of sodium chloride, that's ionic, so its units are formula units. And these can be used as conversion factors. All that stuff we've been working with dimensional analysis. Well, now I know how I can start to go from moles of something to particles or vice versa. We're going to spend some time dealing with that. That's really where we've been going with all of this. But it's just kind of getting our minds wrapped around what is this mole? When I see that, what does that number mean to me? If you have questions, feel free to email. We'll see you again real soon.